Okay, so now we're going to work on trigonometric substitution again, and we're going to talk about the different ways to identify trigonometric substitution, which basically it's just if it's involving the Pythagorean theorem, because the Pythagorean theorem says a squared plus b squared equals c squared, and so if you solve this one, that's like the C minus the B. I don't know why they use the A and the U. I guess just get used to it, how the variables look. But anyway, if you do A squared plus B squared equals C squared. Well, if you solve it for side A, then you get A equals the square root of C squared minus B squared. Okay? So that's these two right here. And then this one is just if you're solving it for C. Okay, so then if you can identify a Pythagorean theorem, then you can identify a Pythagorean identity in much the same way. So, like if you let U be A sine theta, well then you take out the A and you get A cosine theta, because 1 minus sine squared is cosine squared. Okay, so here are the different ideas of it. Is if you have A minus the variable, okay, then your hypotenuse obviously has to be A, because that's C squared minus B squared. And then you let the adjacent leg be the radical. If you have the pluses, then your hypotenuse has to be that, and you let the opposite leg, be the x value or the variable. And then if you have subtraction but you have your variable first, then obviously your variable has to be the hypotenuse, and then you let the radical be the opposite side. Okay, so let's try this one again. So I have a radical, and I'm going to think about what that looks like. Well, that's a subtraction, so that must be that A squared plus B squared equals C squared, or A equals the square root of C squared minus B squared. So if I draw my right triangle and put my theta, and this is like my translator between the two, between x's and numbers and between thetas, then I'm gonna now put the sides on it. So let's see, C is like, well, C squared is like 9, so that must mean that C is 3. And then X is like B, and it doesn't matter which side you put it on. And then this is the square root of 9 minus x squared. And if you're not sure, just check it out and verify it. If you square this and add it and square that and then add them together, your x's cancel and you get the square root of 9, which is, I mean, you get, sorry, you square that, yeah, and you square that, and then they would cancel, and then you square that, and that does equal 9. So, okay. So next we're going to find the relationship. So the sine of theta is opposite over hypotenuse. So then I go 3 sine theta equals x. Alright, so that's one substitution that I can do. And then I need to find this whole, I don't want to put 3 sine theta in there. But I could, if I wanted to, then it would come out to be 9 sine squared, and then factor out the 9, I'd get 1 minus cosine squared. I mean, so it would work out. It's fine. You can absolutely just substitute in all the x's. But I prefer to just go ahead and find what this one is. So this is adjacent over hypotenuse. So then you could do theta, let's see, so then that would be cosine of theta equals the adjacent over the hypotenuse. Well, instead of writing over the hypotenuse, I'm going to write times the hypotenuse here. All right, and then also I need to find dx and d theta. So I'm going to take this one, and I'm going to solve it. I mean, I'm going to differentiate it so that I get d theta. So the derivative of 3 sine theta is 3 cosine theta d theta equals dx. All right, so now I think everything's ready to substitute. So I'm going to do that over here. Okay, so now I get the integral of, all right, dx is 3 cosine theta d theta over, and then x squared is 9 sine squared theta. And then the square root of 9 minus x squared is 3 cosine theta. All right, well, those cancel. So that's nice. So then I get 1/9. And then 1 over sine squared is cosecant squared theta d theta. And then that is negative cotangent of theta plus c. Okay, now I can't finish the answer like that because I need to find the cotangent. So that's not too bad. That's opposite over adjacent is tangent, so adjacent over opposite. So adjacent over opposite. So I get negative square root of 9 minus x squared. That's the adjacent. Over, and then the 9 is already there. And then opposite. Alright, so opposite over, let me make sure, opposite over adjacent, adjacent over, yeah. Okay, oh, and let's not forget the plus c. So basically you can see that as you substitute them, then it makes it actually into an easier one than it was with this one. Because if you tried u substitution with this, then that gives you a 2x, but this is an x squared, so that's not going to work out. But turning it into a trigonometric plane and then turning it back in after you do the antiderivative makes it easier. Alright, so let's try another one. Okay, so this is of the form a squared plus b squared, so this must be c. Alright, so over here, I'm going to draw my triangle again. Alright, and so c is the square root of 4x squared plus 1. And then, so that's 2x, and that's a 1. A squared plus b squared, okay? Alright, and now, oh, and there's my theta. Okay, and then now I just need to do my x, so that's opposite over adjacent, so the tangent, oh no, I want, well, let's see, I'll just finish it out anyway. The tangent of theta is 1 over 2x. That's not as helpful because I want the x on top, so switch it. The cotangent of theta is 2x, so half cotangent theta is x, not that I need that, I just need the dx, and then 1/2, and then the derivative of cotangent is negative, and then cosecant squared theta d theta equals dx. Alright, and so I've got my dx, and then now I need my radical right here. So if I do opposite over hypotenuse, that actually gives me the whole thing, 1 over that. So that would be the sine of theta. So the sine of theta equals 1 over the square root of 4x squared plus 1. Okay, so all of that is sine. Okay, so be careful with that. It's not that the sine goes on the bottom. The entire thing, that is sine. So now I get sine theta, and then dx is negative 1/2 cosecant squared theta d theta. Okay, well, sine and cosecant are reciprocals, so those cancel, so I get negative 1/2 the antiderivative of the cosecant of theta d theta, which is negative 1/2 natural log of the absolute value of the cosecant of theta plus the cotangent of theta plus c. I'm going to have to look that up and make sure I'm right, so give me a second. Okay, so I found it, and I just need to erase my negative sign, because it's negative natural log, but I already had a negative there, so that becomes positive. Okay. Alright, well, I'm not done, because now I still need to translate it back into x's. So cosecant is what? Cosecant is 1 over sine, so it's going to be that, or the reciprocal of that, I suppose. And the cotangent is 2x. There it is. Alright. So the next one is... Okay, so the next one is a squared plus b squared, and that's a square root if you rewrite it as 1 over the square root of x squared plus 1, and then cubed dx. Okay, so there we go. So that's a squared plus b squared equals c squared. So this is the square root of x squared plus 1. And then this is x. Or actually, I'm going to make this x. And I'm going to make this 1. Okay. So then I just need this. So that's adjacent over hypotenuse. So the cosine of theta is 1 over the square root of x squared plus 1. And that's that. And then, which I could write this whole thing here. I could get rid of that. And I could write it the whole thing cubed. That would also be fine, because 1 cubed is just 1. So that'll be fine still. And then I need dx. So opposite over adjacent. So the tangent of theta is x. So then secant squared theta d theta equals dx. Okay, so then this is the cosine cubed theta, alright, and then dx is secant squared, so I get secant squared theta d theta. Well, secant and cosine are reciprocals, so 2 of those cancel with 2 of those. So then I just get the antiderivative of the cosine of theta d theta, which is sine of theta plus c. And then the sine is opposite over hypotenuse, so that's x over the square root of x squared plus 1 plus c. Okay, so now we have an integral. I'm not sure what that is. I think that's a root 3, and that's a 2. I don't have my handouts with me, so we're going to go with that. And that's a root 3, and that's a 2. And then this is c squared minus b squared. So I'm going to draw my right triangle. And then I'm going to make that the square root of x squared minus 3. Then this would be root 3. And this would be, what? X. Right? So x squared minus 3. Yeah. Okay. Let's check that out and make sure. So then a is the square root of c squared minus b squared. Yeah, so b squared is 3, so b is root 3, and c has to be x. All right. Okay, so then now we get opposite over hypotenuse. So the sine of theta is root 3 over x, or we could now multiply both sides by x. And then divide both sides by sine and get x equals root 3. And then if you divide by sine, well, that's the same as writing it as the cosecant on top. So then dx is, and the derivative of cosecant is negative root 3 cosecant theta cotangent theta d theta. Okay. And then now we need what? We need this over this. So you see you can do the radical over the hypotenuse, and that'll give you the whole division there. So what is that? Adjacent over hypotenuse. So the cosine of theta is the square root of x squared minus 3 over x, which is that. Okay, so then we get the antiderivative, and I'm just not going to write the endpoints yet. And then, or I mean, I can change them, whichever one. And then, let's see, that is cosine of theta. And then dx is negative root 3 cosecant theta cotangent theta d theta. All right, so I'm going to bring my negative root 3 out, and then cosine theta, and then that's 1 over sine of theta, and then cotangent theta d theta. So I really have negative root 3, and then that's cotangent right there, and then I have another cotangent. So then that gives me cotangent squared theta d theta. Okay, so then we need to figure out the antiderivative of cotangent squared, which I don't know the antiderivative of cotangent squared. If it was cosecant squared, I would know it, but let's see. So let's change this into cosine squared over sine squared. And let's see, so if I change that into 1 minus sine squared, so I'm going to change the cosines into sines and see what happens with that. I don't know if this is going to work, but it's good to experiment. Try and try again. So that's 1 minus sine squared theta over sine squared theta d theta. So then this gives me, all right, 1 over sine squared is cosecant squared theta minus 1 d theta. Oh, well, duh, I could have just changed cotangent into that, couldn't I? With the Pythagorean identity. Whatever, here now. Okay, and I do know the antiderivatives of these. So this is negative root 3, and then the antiderivative of cosecant squared is negative cotangent theta minus theta. And then I'm going to have to do, I'm not going to put the plus c because I'm going to have to do an actual integrand, a definite integral. Okay, and then now I need to change cotangent. So cotangent is what? Adjacent over opposite. So that's root x squared. Oh, that's cotangent of theta. Root x squared minus 3 over root 3. That's adjacent over opposite. All right. So distribute that in. And I get root 3. And then the cotangent is root x squared minus 3 over root 3 plus root 3 theta. Okay. All right, and then now I need theta, and it doesn't really matter which one you use. You can use any of them that you want, but generally I'm going to use the one with the x's in it. So if it doesn't, let's see, opposite over adjacent, I mean opposite over hypotenuse, adjacent over, it doesn't really matter. So let's just go with the one we have right here. So theta is just, before I did this x thing, just left it here. So the sine of theta equals root 3 over x. So then theta is the arc sine of root 3 over x. Okay? So then I get square root of x squared minus 3 plus root 3 arc sine of root 3 over x. Okay, and now I'm ready to do it. So this is root 3 to 2. Right? Root 3 to 2. Yes. So then now I can plug that in, and that gives me the square root of 4 minus 3, which is just 1, plus root 3 arc, what I was drawing there, arc, that's terrible, let's try it again, arc sine of root 3 over 2, oh, that's a nice one, minus, and then I'm going to do all this, so then root 3 goes in there and I get root 0, plus root 3 arc, I'm dyslexic today, always, but especially today, and then arc sine of 1. Okay, so then that is 1 plus, okay, and then where is arc sine root 3, where is sine root 3 over 2? That would be in quadrant 1, the pi over 3, so that would be root 3 pi over 3 minus, and that's 0, and then where is sine 1 is straight up at pi over 2, so root 3 pi over 2. And you can join them together if you want, but I don't want to. Okay, when using trigonometric substitution to evaluate definite integrals, you must be careful to check that the values of theta lie in the domain of the arc function you are evaluating. For example, if the integral above had been from negative 2 to negative root 3, then sine of theta is negative root 3, which is not 5 pi over 3. Okay, so what this is talking about is way back when we learned about inverse functions. Arc sine has to come out here or here. So you can only answer from pi over 2, from negative pi over 2 to pi over 2 for arc sine and arc tangent. And then arc cosine can only be answered from here to here. Okay, so that's the end of 8.4. I highly suggest you do some homework. Check it out and try it out yourself.